Hi everyone, and welcome to the AWS Nordics Ask Me Anything office hours. My name is Gunnar Grosch, and I am a developer advocate here at AWS. And I'm going to take you through this hour of AWS knowledge sharing. We, as usual, have a topic to talk about, but this show is, as usual, very much about you, so our viewers, and the questions you might have about AWS or the specific topic. So if you have any questions, just post them in the chat and we'll do our best to answer those. And this week, I am joined by Specialist Solutions Architect for Machine Learning, Vikesh Pandey. So welcome to the show, Vikesh.
Hey Gunnar, thanks for bringing me here, and happy to be here and discuss about my favorite topic, which is around machine learning.
Yeah, and so you are a specialist solutions architect for machine learning. So what does that role do within AWS?
Yeah, sure. So as a specialist solutions architect, my prime responsibility is to work with the strategic opportunities we have in this region, strategic customers we have in the region, and try to solve the complex business problems which customers have related to artificial intelligence or machine learning using the capabilities we have in our AWS ML stack. So, I mean, these use cases range from different variety of, I would say, business segments, be it a recommendation engine or a forecasting engine, or it can be a simple, say, fraud, no fraud kind of use cases, or even for computer vision kind of applications. So I cover a variety of AI ML use cases, but the main, say, intent is to help our customers maximize basically the capabilities which we have in our AWS ML stack and build those solutions.
And today we're seeing use cases for machine learning popping up everywhere. And the services that we have for that uses machine learning, it might be different managed services that are using machine learning, or it might be more of machine learning services like Sagemaker, where you are doing things that are related to machine learning. So tell us, Vikesh, a bit about what does the machine learning lifecycle look like?
Yeah, sure. I think even before we go there, you actually touched upon a very good point about how do we see the customer personas. So we have we basically I use the word ML stack, so I just wanted to clarify before we jump into the ML lifecycle. So we have we basically divide our ML stack into 3 layers. First layer, we call it as AI services layer, which is targeted towards the developer community who do not have machine learning experience or expertise, I would say, but they still want to leverage the power of machine learning. So we build these pre-baked services around recommendations or forecasting or computer vision use cases, which customers can directly start using without training their own model. Then we have the managed services layer, which is heavily dominated by Sagemaker, which is basically built for data scientists who want to have a fully managed experience to work in their whole end-to-end machine learning lifecycle. And then we have the third layer, which is for advanced customers, where they want to go completely, I would say, in a DIY mode, where they can choose their AMI, choose their container, choose their acceleration types, and build their own stack. Now, coming to to your questions around how does a machine learning lifecycle look like? It looks very complex and iterative, I would say. So we start with the data ingestion, where we create sort of a data lake. We just dump all of the data with all the versioning and other capabilities which we require in a data lake. Then we start with the data preparation, where we start exploring the data, understand the patterns in the data, find outliers, distributions, standard deviations, etc. Do some feature engineering on the data or the cleansing on the data, do any kind of transformation on the data. So that's all goes into the data preparation / transformation phase. And once our data is good and ready to be thrown into a machine learning algorithm, so we move to the training phase, where we train a machine learning model by maybe trying different algorithms or different recipes, different hyperparameter settings, different set of data instances as well. So we go into that iterative process, trying to find the best model. And once we have that sort of an optimal model, then we deploy that model. And the story doesn't end there, because once you have deployed the model, then you need to monitor the model for its quality and performance metrics. And when I say quality and performance, I mean, basically we are looking at how good the model is at making real-time predictions. And once you start talking about monitoring, you start talking about ML ops practices where you would like to automate this whole cycle of ingestion to preparation to training to deployment to monitoring back to ingestion. So that's what we define as sort of an ML ops cycle, and that's how the machine learning life cycle will gradually evolve into.
Right. So starting with the first part then, data preparation. Should we straight away jump into a specific service for data preparation, perhaps?
Absolutely.
Yeah. So tell us what we're seeing on screen right now, Vikesh.
Yeah. So since we are talking about data preparation area, as per multiple public surveys reported, 80% of the data scientists' time is spent into data preparation tasks. So it's a huge pain for data scientists doing this manually over and over again, trying to find the right distributions and patterns in the data. Maybe you need to drop the null values. Maybe you need to impute the null values. Maybe you need to one-hot encode the data or categorically encode the data, do label encoding, maybe rename some columns, as simple as that kind of transformation. So it's a lot of work. It requires a lot of analysis. And we saw data scientists spending a lot of time on this. So we try to simplify this. And we try to create a sort of a UI-first tool called Sagemaker Data Wrangler, which you can use to do all of these tasks literally without writing even a single line of code. So you don't have to code it at all. It's all point and click and drag and drop kind of experience in Data Wrangler, which you can use to build your complete data preparation flow. But at the end, you would need it to be converted into the code. So Data Wrangler also provides capabilities to export the whole data flow which you have created inside Data Wrangler to a Python notebook or to a pure Python script or to even a feature store if you want to, which is another offering in SageMaker. So what you see right now is basically sort of the home screen of the Data Wrangler view. And if you actually want to start it from the step 0, so it's as simple as going to File, New, and you hit this option as Flow. If you click on this option, you will see this message which you saw, which says connecting to Data Wrangler. So what is happening in the background is basically the SageMaker Studio, the studio which you're seeing right now, is spinning up a container in the background, which is a Data Wrangler container. Once that container comes up, it connects to SageMaker Studio, and you are up and ready to go. It takes roughly 2 to 3 minutes to basically spin up that container. And before I go further, I should also introduce what you're looking at the screen right now. It's our purpose-built machine learning IDE, which is SageMaker Studio. And the idea behind creating this particular IDE was to give data scientists a single pane of glass for doing literally anything in the whole machine learning life cycle. So be it data preparation or tuning, experiment tracking, training, deployment, ML ops, model monitoring, all of that is embedded into the single IDE. So as a data scientist, you don't need to switch context and go to multiple different consoles and understand their different constructs. So this is the SageMaker Studio.
Yeah, so many of the SageMaker or all SageMaker services that are released are then integrated into SageMaker Studio.
Yeah, that's a good point. So when we talk about the new services, our approach towards machine learning has always been to make it as modular as possible. So most of the features which we launch, in fact, barring the SageMaker Data Wrangler, which I'm talking about right now, apart from that, all of the other features which we launched are purely SDKs, which you can use even outside SageMaker Studio. But if you use them inside SageMaker Studio, you get all the visual components of this IDE for free. So you don't need to build those visualizations by yourself. That's the whole value proposition of SageMaker Studio here. For Data Wrangler, since this is a purely UI-driven tool, so this has a tight dependency on SageMaker Studio. So if you're using Data Wrangler, you will have to use Studio.
And talking about the data then that we're going to use to prepare, what type of data could this be? Can you give examples of data?
Yeah, as it supports currently CSV and Parquet as the data formats to deal with. And when it comes to data sources, as you can see on the screen, S3, Athena, Redshift, and Lake Formation are the 4 data sources which we have started with as a native integration. And as we go further throughout this year, we plan to add more data connectors, for example, for Databricks or Snowflake or MongoDB. So we have those in the pipelines as well, where we'll try to add those as a connector as well. So in today's demo, I'm going to just use the S3 native integration and use a sample CSV, which is basically a data set of Titanic survivors who survived and who did not survive. So we will just use that data set and we will try to do some exploration and some massaging on the data set. So let's get started. Any questions, Gunnar, before we go further?
No, let's go ahead.
Cool, awesome. So once you go to the once you do file new flow, you come to this particular screen and you can see the connection options. So you can just click on Amazon S3. It will list all the buckets which you have. So you can go to the bucket where you have placed your data. And this is the CSV file which I'm dealing with, which is basically having the details of all the passengers who either survived or did not survive. So the moment you do the import and you just select on the CSV, you see something happening on the screen. Automatically, Data Wrangler shows you a snapshot of the data. You did not write even a single line of code to just have a view of the data, but this just worked. So that is sort of the kind of capabilities we are talking about when we say that you don't need to write any code. And I will go further deeper into this particular aspect. So this is just a snapshot of what the CSV is having. You can change the name of the CSV if you want. The S3 location is here. And the file type, like I talked about, you can also change if you think the Data Wrangler did not detect the type correctly, you can change it between CSV and Parquet. So I'll keep it as CSV. You also can and should tell Data Wrangler if the first row is the header row. And sampling is basically for another interesting capabilities of Data Wrangler, which will do a quick modeling on your data. Because once you do the data exploration, you would like to know, okay, I think I'm good, but does it result into an optimal model? So what Data Wrangler will do, that it will take a sample of your data set, and it will basically create a very quick model in few seconds. And it will show you the performance metrics of that particular model. So you can judge whether the model is good enough or not. If it's not, probably you need to change the data representation more. So you go back to the data exploration phase. So on this screen, you just hit on import dataset, and then this kind of screen will be presented to you. If you notice another thing, we moved from import to the prepare tab here. And this is basically the complete flow of Data Wrangler, which is import, prepare, analyze, and export. So we have done the import part. Now we're in the preparation part. So here you see this plus icon. And if you click on this, it gives you multiple options for data transformations. You can edit the data type of your columns. You can add transformation rules to your columns. You can add analysis in terms of creating histograms or table summaries or bar charts or box plots, etc. You can also join multiple workflows. That's something which I will talk about later. So let's click on add analysis for now. And again, you see different visualizations preloaded for you here. For example, in the analysis type, you can create a histogram. You can create a quick model, scatter plot, table summary. So let's click on table summary, for example, and hit preview. Once you hit preview, it will generate a table summary pretty quickly for you. And you can see the count, the mean, the standard deviation, the min value, and the max value for all the columns, like the passenger class, survived, name, gender, age, and some more details like ticket, class, fare, which cabin they were in, which boat type they were in, etc., etc. So if this summary looks good to you, you just name it something. Let's call it as table summary, and you hit preview again just to generate the data, and you hit create. Once you create, the analysis will be created for you. So this is one analysis which you have done. You can do more analysis like this, creating a histogram or creating a bar chart and understanding the data's representation better. This will also give an understanding of what are the outliers in your data in terms of basically data distribution. For example, you might be able to spot how many values for a particular column is missing. If you see that the mean is completely different from the max value, for example, if the min age is 32 and max age is hypothetically 500, and the mean is somewhere 100, then you can understand that there are a lot of outliers in this particular column, which you need to fix. So those kind of data engineering techniques can be applied here to understand the data better. And once you have done that, you can go back to the prepare phase. You can see this icon here because we have added an analysis step here, which is visible here. And now we can add some transformation rules here as well. So if you click on transform, you see all of these transformation rules created. So Data Wrangler provides more than 300 built-in transformation rules for you, which you can just use out of the box without writing even a single line of code. These transformation rules can be as simple as, let's say, dropping certain columns or duplicating columns or rename columns. It can be as complex as handling outliers via the standard deviation numeric outliers or quantile numeric outliers. It can also be doing some categorical or one-hot encoding. So you can go through all of these different transformation rules, which we have coded and pre-baked by default in Data Wrangler, and just use them. And if you want to add something of your custom, then that's also an option. You go to this first option, which says custom transform. You click on this, and here you can add your code either in PySpark, Pandas, or SQL. So just write your custom transformation code here, and that transformation will be applied on the data frame. You can also add some custom formula as well if you want to in a Spark SQL expression, if that's something which you are already familiar with. So a lot of pre-baked rules. At the same time, a lot of flexibility is what we are aiming for here. So for example, I can go to as simple as manage columns and drop some of the columns which I know are not going to add any value to my model. For example, the cabin information is not of any use for the model. So I can just go here and select cabin and select preview. And you see the cabin column would be gone from here quickly. There's no cabin column here. I can click on add. Once I click on add, this transformation rule is now added to my data flow. So I can do the similar thing for ticket number, because ticket number again is not going to decide who is going to survive and who is not going to survive. So you can do the same here. Go here and select ticket number, click on preview. The ticket column will be gone from here. So if I scroll to the left, I don't see that column here. Hit on add. So similarly, you can add as many rules as you want. And if you click on previous steps, you will see all the step summary here, as well as here, if you go back to the prepare stage here. So now let's say you are good with everything which you have done in terms of transformation rules. You added columns, you dropped columns, you did one-hot encoding and whatnot. And now you want to export this whole flow into code. So you go to the export tab here. And here, if you click on the last step of your flow, this flow by default, by the way, is pretty responsive. So you can zoom out, zoom in, move things around here as well. And if you had more workflows, you can join and concatenate more than one workflow as well. Let's say you had two different CSVs, you created two independent flows, and then you merge the data of both of those CSVs into a single CSV. So that's sort of the join operation we are talking about. You can also concatenate, which is technically a union of tables, which you can also do. So let's say you're good with everything. So you go to this particular step. Here it will show you all the steps of transformations which you have applied. You select the last step. And the moment you select that, you see the export step option enabled here. If you hit that, you get an option of how do you want to export this whole flow into a code. Do you want to export it as a Data Wrangler job, as a pipeline, as a pure Python script, or directly into Sagemaker feature store? So any option you click, all the code, all the plumbing code for it will be automatically generated by Data Wrangler. For example, if I click on Data Wrangler job, now you will see that it automatically created a notebook. I can select a data science kernel here, and all the code of my transformation rules is automatically written, which I can directly wrap into a script, into a container, into a workflow step in pipelines, or anything else. Similarly, you can also export this into a pipeline step directly by using the whole MLOps concept. You can also export it as a bare-bone Python code and add it as a package or a module or as a dependency anywhere else you want. So this is sort of a very quick lightning overview of what Data Wrangler's capabilities are all about in terms of giving you the flexibility of using more than 300 transformation rules by default, adding your own transformation rules, providing multiple export options in terms of whether you want it as a pipeline step or as a processing step or as a pure Python code as well, or also in the feature store directly if you want to. So hope this was helpful. Anything which stands out or I missed?
No, but it's really cool. When I get quiet in these stream sessions, it usually means that I am deep into what you're showing. So in this case, I think I was quiet for the entire time. Really cool to see how you can use Data Wrangler for preparing your data, because as you mentioned early on, that takes up a lot of the time when you're about to train your machine learning models, preparing the data. So you showed an example with one CSV file here, but you mentioned that you're able to use multiple files and then join that data together. Are we able to show an example of how to do that just quickly?
It would be more work because I have some sample CSVs, but I need to actually import all the CSVs and show the join and concatenation rules based on the unique columns. Okay. So I think in the scope of this live stream, probably I'll not be able to do that. But right. Yeah, if I'll be happy to record a session and put it on our channel. Yeah,
for sure. So that was the data preparation part. We do have some questions in the chat, but I think I'll save them for the appropriate time, so we can add them when we're talking about pipelines, for instance. We just had a few that were a bit more generic. For instance, let's see. Just Call Me Port is asking, what's the demand like of machine learning? So you, as a specialist solutions architect for machine learning, you probably know exactly what the demand is like.
I think let me start this by saying that we are still scratching the surface of machine learning. So a lot of customers and a lot of business personas they don't still even know if machine learning can be used in their business use case. So the demand is very high in those areas which have already been identified as something which can be solved with machine learning. But there are still tons of other use cases which we still haven't even reached towards, which can be solved with machine learning. So the demand is, I would say, pretty high today in terms of looking at the specialization of it. That's why you see the data scientist is probably one of the most in-demand job title today. And apart from that, even if you move away from data scientist, the whole paradigm of machine learning brings new set of disciplines and skills. ML ops engineer is a bit different than DevOps engineer. You have data scientist, you have data engineer, you have SMEs as well for the particular domain, which basically understand the domain well and how they can see the machine learning can be applied on the domain. Because the hardest challenge when we talk about machine learning is defining the business problem as a machine learning problem. That's where most of the customers get it wrong, and that's where we jump in and we try to help the customers.
So if you just join us, this is the AWS Nordics office hours. My name is Gunnar. I am joined today by Vikesh Pandey, and we're talking about machine learning, and we've just gone through the first step of data preparation using Data Wrangler. So now let's move on to the second phase of the machine learning lifecycle, which is training the model. And we're not going to show all of the steps involved, perhaps, but you mentioned that cooking show style, so a bit of preparation before the show. But let's jump into it, Vikesh.
Yeah, and for the record, I'm a really bad cook. So, so we are just trying to basically sort of mimic the whole machine learning life cycle here, where we did some data preparation. And let's say you are happy with the results, you're happy with the refined CSV file which you have, which you think is ready to be funneled into a machine learning algorithm. So the next challenge, the natural challenge for a data scientist would be to decide which would be the right algorithm to choose, which would be the right evaluation metric to measure the model's performance on, which all would be the right hyperparameter ranges and values for the algorithm, which would be the right sizing of the data set, which would be the right sizing of the instance, how big of an instance do you need, how much vCPU, RAM. So it's a lot of decisions which data scientist has to make. And on top of it, where to run this training. Do they want to run it locally or onto an ephemeral cluster where that cluster would be sitting in? So there are a lot of questions which a data scientist has to answer. And if you realize some of those questions are not really related to data science directly. For example, how the training cluster should scale is something which a data scientist should not spend their time on, because they just should focus on solving the business problem. This is something which should be done maybe by an infra engineer or maybe a cloud provider like AWS. So we try to simplify the whole friction in the training process from the persona of data scientist, and we try to provide a more and more managed experience to data scientists. So to basically walk you through that use case, yeah, Gunnar?
A question on that then. What is the difference between data scientist and data engineer?
Awesome, great question. I was expecting that question to be coming. So data engineer is somebody who only focuses on data transformations, building ETL pipelines, changing the representation of the data, maybe cleaning up the data, like I did, dropping some columns, doing some imputations on the data. So that is something which a data engineer will do. Data engineer is also responsible for some part of managing the data lake, making sure that the right connectors to the data lake are there, make sure that, because when you talk about data lake, a lot of data is going to be dumped there, right? Who is going to make that whole messy representation of the data into a nice representation? That's the job of data engineer. And when we talk about data scientist, it sort of feeds into, it basically takes the output of the data engineering process, I would say. So a data scientist's focus is on actually the whole training tuning part, where they basically play with the data, do some feature engineering on the data. So feature engineering is also different from data engineering. When you talk about feature engineering, it's very, very specific to the machine learning algorithm or the machine learning problem you're solving. For example, a machine learning algorithm does not understand text. It understands vectors. It understands tensors. So you need to change your data's representation from like the columns like customer name, etc., to something which is a mathematical representation of this data, which we do as part of feature engineering by using frameworks like sklearn or something. So that's something which data scientists will do. And once they are happy with the data, then they try with different algorithms, different hyperparameters, different configuration parameters. And this is a highly iterative process which a data scientist would do. And that's where most of the data scientists would be working in. A lot of startups also merge these two disciplines into one, where a single person is also donning both of the roles. So it depends, but this is the sort of the classic definition.
All right, great. So continue.
Yeah, great, awesome. So for showing you how to do the training on SageMaker, I have prepared another notebook here, which is showing how to train a customer churn prediction model using XGBoost. So XGBoost is one of the gradient boosting algorithms, which is very popular. It's probably one of the most popular algorithms in Kaggle competitions as well. And as part of SageMaker, we provide XGBoost as a pre-built container. So when I say pre-built container, what we mean is that you do not need to worry about how to bring the XGBoost algorithm or the whole XGBoost environment inside your training space. We cooked a container, we put that into our ECR URI, and you can just start using it. So that's the basic idea when I say SageMaker containers or XGBoost containers. We also provide all of other different container support. For example, if you want to use TensorFlow or PyTorch or MXNet, so we also provide pre-built containers for all of those capabilities, where you can just start using the container and just build your training script and start the training. And for the record, PyTorch and TensorFlow containers on AWS, they run faster than the open source TensorFlow and PyTorch containers. So this particular use case is around customer churn prediction. Like I mentioned, I've already executed this Jupyter notebook, so I'm just going to focus on the important areas. Here we are dealing with the data of a telecom operator, where a telecom operator has captured the data of their customers and saw that which customer left their platform and which customer stayed on their platform. So here, if you see this churn column, true or false, true means that the customer left the platform, and false means that the customer stayed on the platform. And you see other details like international charges, how many international calls the customer made, how many international minutes the customer spent, night charges, etc., account length in terms of in number of days, which state the customer belonged to, etc. So this is sort of the data we are dealing with. And I'm not going to go through the feature engineering steps here because that's something we already covered. But here in this notebook, what we are doing is basically understanding the distribution of the data better by creating different kind of plots here. You can see for each particular column, I'm creating a distribution chart to find the outliers for a particular column, dropping some of the columns, creating more bar charts to see the correlation between different columns as well, and also generating some heat maps here to understand the correlation of the data better. I'm also dropping some of the columns which are not relevant for my this particular model. For example, the evening charges or the night charges are some of the columns which do not contribute to the decision whether the customer stayed on the platform or left the platform. But where the SageMaker things kick in is basically starting from, I would say, here. So one of the basic idea behind machine learning training is that you three-way split your data, or at least two-way split your data. So you build a training section of the data. You have, let's say you have a single CSV. You basically divide the single CSV in three sections. You create a train.csv for training. You create a validation.csv to measure the performance of the model we test with some I would say tuning. And then you also keep a test data set to do real inference on the data on the model to see how good the model is. In this particular use case, I just have two splits, but like I said, you can make three splits as well. So I have a train split and a validation split. I created these two CSVs, named them as train.csv and validation.csv, and just uploaded them to S3 bucket. Once the data, the CSVs have made to the S3 bucket, the next thing I want to decide is which container I want to use. So like I mentioned, in this particular case, I'm using XGBoost. So I provide the name of the container, from which region I should pull this container from, and this is basically the version information. And here you can see I'm using a Sagemaker Python SDK construct. So when you're building your machine learning training solution, you can either use the AWS SDK for Python, which is the Bodo 3 library, or you can also use Sagemaker Python SDK, which is tailor-made for Sagemaker itself. If you're starting with it, I would suggest to start with Sagemaker Python SDK, as you will have to write less boilerplate code, and you will get things done faster. So here we just retrieve the XGBoost container. The next thing which we need to specify for SageMaker is channels. So SageMaker understands the concept of channels as sort of you can think of it as a symlink technically, or a pointer to a particular location. So you need to tell SageMaker where the training data is sitting and where the validation data is sitting, which you do by calling the training input constructors here, supplying the source location and the content type. So we do that for the train and validation. And then we create the estimator, which is a generic SageMaker estimator. So you create this estimator, you specify the container, which is the XGBoost container, ECR URI. You supply the role, the number of instances you need to do this training. So here the instance count is 1. If you change this instance count from 1 to, let's say, 3, or even, let's say, to 2, the moment you put it as greater than 1, it will automatically kick in a distributed training, provided you have the data correctly sharded and your algorithm supports it. XGBoost does support the distributed training paradigm. So in this case, if I change this to 1 to 2, it will kick on distributed training. But my data is pretty small, so I don't need that. I'll keep it to 1. We can specify the instance type here based on how much VCP or RAM you need. We have a lot of EC2 instances which are available. And if you want to know which are machine learning types, then do check out this ML extension. So all the instances which start with ML are tailor-made for machine learning workloads. You specify the output path where the actual model will be stored and provide the session. Once you have created the estimator, you can provide some configuration parameters or hyperparameters. In this particular case, you see that fixed values. which will never be the case for you. It will always be ranges. So let's say you provide the max depth range as 1 to 10, and then SageMaker will automatically find the right value for you if you use the hyperparameter tuning concept of SageMaker. In this particular notebook, I'm not using the tuning concept, but these are some of the configuration parameter values which are specified along with the objective on which I want to measure the model's performance. And then we just call fit, provide the train channel, provide the validation channel. It will automatically spin up a cluster here. So you see, it says starting the training job, launching the requested ML instances, and it will automatically launch the cluster under the hood, pull on the data, do the training, tear down the cluster. Everything will happen with a single command, and you don't need to do anything in terms of managing the cluster. So that's the whole managed training experience. And once your model is trained, then you can just deploy the model using the same estimator object. Just call deploy, provide the number of instances, again, the instance type, and what type of content type your model should take in. So in this case, my model was trained on CSV data, and I know that my inference data will also be coming in sort of CSV inputs. So I need to specify the right serializer here, which in this case is the CSV serializer. And once you have deployed the model, it's going to take roughly 5 to 7 minutes, depending upon how complex the model is. And once the model is deployed, then you can just call the predict method and start doing the predictions, which I'm doing in this particular method. And once you do the prediction, then it is pretty much up to you on how you want to measure the model's performance, whether you want to measure it based on building a confusion matrix, which I've built here. It's basically just using the pandas crosstab method to build a confusion matrix here, or you want to move out the threshold, you want to look at an F1 score, or you want to look at a precision or recall. Depends upon what kind of business problem you're solving. For example, for binary classification, all of which I said is true. For a regression problem, there would be other kind of metrics which you will be looking at. So it depends upon what you want to measure on from here on. Just throw in your test data set to this predict method, measure the accuracy. When you're happy, just migrate this model to, let's say, a staging environment. So that's pretty much what I wanted to show you in terms of how quickly you can build and train and deploy the model. So if you see technically, it's just probably 3 to 4 different API calls, which I made here to train and deploy the model. So that's easy. It can be for a data scientist to get started with it. As far as learning the SDK is concerned, SDK is pretty much, I would say, developer friendly. I mean, I learned this SDK pretty fast. So if I can learn it, probably everybody can learn it. So that's how I measure it. I measure the ease of its use. So I think that it has a smaller learning curve in terms of understanding the SDK constructs and just start using them.
But in this case, there are quite a lot of rows involved here. But how much of this have you written, and how much have you just changed different parameters?
I would say, I mean, most of this is, I mean, can you rephrase the question as to saying changing things?
Yeah, have you written this from scratch, or have you changed parameters for it to be adapted to the training you're doing?
I changed few things. For example, I changed some of the feature engineering steps just to understand the data better. This notebook is available as part of our official GitHub repo as well, the Amazon SageMaker examples repo. And I changed some of the hyperparameter values just to make the training faster, because I've run this notebook tons of times, so I know what values work here. So I think those are the changes which I did. Apart from that, rest of the code was something which I just reused from our repo.
Right. Okay. So now we've gone through preparing data. We've looked at how to train a model, and then on to the last section of our session today, which is around pipelines or MLOps. So can you explain what MLOps means?
MLOps, if you already are using DevOps practices, then it means very similar, basically to build a cross-functional team of ML engineers and data scientists, which can work along, and they can share the artifacts without much friction. They can deploy things, they can monitor things without much friction, and build the whole life cycle in sort of a continuous delivery fashion. So pretty much the same principles which apply on SDLC, they apply on the ML life cycle as well. There there are just changes in terms of the perception, I would say. And the perception is that when you work with SDLC, a major part of operationalizing your workflow is code, the real code, the business logic. But in this case, that real code or the business logic is probably the smallest part of the MLOps lifecycle. It's just a model and some inference code, which you actually have written. Apart from that, it's a lot of plumbing work of how to connect the data preparation flow to the training flow, to experiment tracking, to deployment, to monitoring, when to trigger a retraining, etc. So it's a lot of plumbing around this whole machine learning model and code. And MLOps tries to solve that particular problem to automate this whole process so that you don't have to do this manually and iteratively again and again.
Right. So let's then look at an example of how to build a pipeline.
Absolutely. So when we talk about SageMaker's approach towards implementing MLOps, recently at reInvent 2020, we launched SageMaker Pipelines, which is sort of the purpose-built CI/CD service, or I would call it as feature, which we integrated in SageMaker and SageMaker Studio to help the machine learning engineers and the ops engineers build the MLOps lifecycle quickly. There are multiple moving parts which I want to talk about. Probably I'll spend a minute on this. So when we talk about our approach to MLOps, we created SageMaker Pipelines as an SDK. At the same time, we also created a model registry, which you would need to basically be there to store your models, track the lineage of the models, track the metadata of the models. The second piece is around feature store. Probably you would like to have an integration with feature store as well when we talk about the whole machine learning pipelines. The third thing is around the data lineage part. How do you track which data was used to train which model? Where was the training model sitting? Where was the training data set sitting? What was the validation data set? So the whole visibility and traceability aspect of it. So we tried to attack it from multiple directions, and we came up with this SDK, which is a SageMaker Pipelines SDK, which helps you create a stateful workflow engine within SageMaker. And the moment I use the term stateful workflow engine, some of the people in the audience might think that it might be using step functions under the hood. No, it doesn't use step functions under the hood. This is something which we have built from ground up, from zero. And it's a purpose-built directed acyclic graph, which we have created inside SageMaker Pipelines. So for that, I have already run this because the SageMaker pipeline takes some time to execute. So I created the pipeline pre-hand. So if you go to this last icon, I don't know what to call this icon. I call it as triangle looking icon. So if you click on this and here, you will see multiple options which are features here. So you will see pipelines here. You will also see projects. Maybe start with projects. So what is basically a project? Let's hit on create project. So when we talk about the MLOps pipeline, I talked about automating the whole cycle, right? So what we suggest to the customers is to create your MLOps templates, publish those templates in the service catalog registry, and then your data scientist teams can just provision it as a product inside the data science studio domain itself. And in this template, you codify the whole pipeline, the processing step, the training step, the model evaluation step, the deployment step, and then you also hook in your CI/CD services. It can be the CodeStar services, which are provided by AWS. It can be your own CI/CD services like Jenkins or Circle CI. And then you can also hook your model registry with it, do the lineage tracking. So it's pretty modular in that way, but you can cook the whole template and put the template into the service catalog registry. Once you do that, your team will be able to see the templates under organization templates. Currently, you don't see here anything here because I haven't created any custom template. But the moment you do that, your custom templates will be shown here under organization templates. Apart from that, SageMaker also creates some of the pre-built templates for customers to get started quickly. For example, we see customers doing three things mainly. We see customers building a training pipeline or a deployment pipeline or a training plus deployment pipeline. So we created three MLOps templates inside the SageMaker service account, and we provided that to customers. So if you select a particular template and if you deploy the template, all the code for a sample pipeline using an abalone dataset would be created for you. The pipeline will automatically run. It will show you how a continuous delivery pattern looks like. I'll just run it in the background while I show you a pipeline which I've already run. So I'll just call it as test pipeline and hit create project. It's going to take some time, but we are not going to wait for it. So this is the pipeline which I created already. So I use the training and deployment template and I created the project. Once I create the project, I see two different repos here, one for model build and model deploy, which you can also clone, and you must clone it if you are actually planning to change it. So you clone it, it will come inside your directory, change the code to whatever use case you want to use, but still keep the overall structure in place. So like I mentioned that the project will basically be having the code of a pipeline itself. And the moment the project is created, the pipeline will kickstart. When the pipeline starts, you will see an entry here. And if you double click on this pipeline, it will show you all the executions you have done for this particular pipeline. You can click on a particular execution. And here it will show you the directed acyclic graph, or the DAG I was talking about. So here is the visual representation of your complete workflow, which starts from pre-processing step to training step to doing model evaluation, which is basically checking the mean squared error for the abalone dataset model. And once the value is good enough for the mean squared error, I register the model in the model registry. So this is my training pipeline, only the training pipeline and not the deployment pipeline. So the green steps here basically mean that the step successfully executed. If this was gray, which meant that the step is yet to be executed. And this is not a read-only graph. It's pretty, I would say, informative and intuitive graph. You can click on particular step, and it will show you the output of that particular step, where you can find the logs of that particular step, and additional metadata in terms of what parameters this step took in. So similarly, I can click on train. It will show you the training instance type which was used. Output basically is the root mean square error value and the validation root mean square error value. This is the model, which was the actual output, and the location of the model, and the parameters and the logs, etc. So this is how the DAG looks like. This is the parameters which I already talked about, and some additional settings. You can also download the pipeline definition if you want to export it and reuse it. Just download the pipeline definition. It will be a JSON file. Change it, share it, or whatever you want to do next with it. Coming back to the previous tab, so we talked about the whole pipeline part. Now let's talk about some of the more parts if I go back to the project. If you can also hook in any autopilot experiment to it, which I have not done yet, but if you want, you can hook in an autopilot experiment and track that as part of the pipeline as well. Under model groups, this is the model registry part. So the moment your model gets registered, a model group will be created for it automatically. Once you double click on this, it will show you the current version of the model. So you see version 1. If there were more versions, you will see the 1, 2, 3, the natural sequence of the versions. The status says pending because I just ran the training pipeline. I did not run the deploy step. So let me show you how this works if you're just reusing one of the existing templates. So if you double click on this, it will show you the details, and the current status says status updated to pending manual approval. This is mimicking a continuous delivery pipeline here, where somebody needs to manually approve the build to move to the next stage. And you can do that within the Studio IDE by clicking on the update status. If I go here and click on update model version status and change the status from pending to, let's say, approved, I can provide any comments if I want to, and hit update status. And once I hit that, you see another row here. And now we have 2 rows here. So you also get the lineage of the different steps which you performed on a particular model. This was the previous step, and this is the new step. And you see the username who actually modified the status of the model. The status has changed to approved. And what is happening in the background, that our code pipeline execution is in place, which is now deploying this model to a staging environment. So once the model gets deployed, you can do testing on the models. And once you're happy with the testing, an MLOps engineer will go back to the code pipeline and will migrate the model to a production environment. Let me show you what's happening in the code pipeline space here. So if I go to code pipeline, you will see there are a couple of them in progress right now. So, but this is the one which started just now. So I will click on this one. So let me see if I'm looking at the right one, or this is the one which started 3 minutes ago. Yeah. So this is the one which is currently deploying to the staging environments. You can see this is in progress right now. And once the deployment is complete, this step will pass. Then you can do some testing here, which is just some very vanilla testing as part of this template. And then it will be stuck on this particular step, approve deployment. So some MLOps engineer needs to go to this console, approve this. And once they approve this, the model will be migrated to a production environment. So this is what we provide as part of Sagemaker projects, which integrates our Sagemaker pipelines under the hood. If you do not want to use Sagemaker projects, feel free not to use that and just use the Sagemaker Pipeline SDK APIs to just build your raw pipelines with your model registry, integration, and with the whole continuous delivery aspect, and also bringing your own CI/CD paradigm to it. So projects is just an opinionated prescriptive guidance which AWS provides, which you can use or you can choose not to use it. For customers starting with it, I would suggest to just try out Sagemaker projects and just steal the code, just steal with pride. Just take all the code which is already pre-generated and change it as per, because this is a sample abalone pipeline using XGBoost. Just change that abalone data set with your own data set. Change the training code, change the model evaluation code, but just use the whole structure, the whole continuous delivery structure which we have created under the hood. So I've spoken a lot, and I'm not sure if everybody followed along or this was information bombardment here.
No, I think so. I was quiet once again, and that's a good sign. It means that it's interesting. And I really like to see how it integrates with Code Pipeline, because that's something that many customers are using today already. And but in this case, you don't need to do any work to have that pipeline set up in Code Pipeline. That's handled through SageMaker pipelines or through the project.
And this is the code which I've already cloned for this one. So if you go to the model deploy one, you will see the model build spec YAML. You will see the configuration JSONs. You will see the endpoint config template, the build.py. So all the code which is basically hooking up all the CodeStar services is there, which you can change and iterate upon.
Cool. We got a question early on pipelines. I saved that until we got to this section. So let's put it up on screen. So how do you best handle processing large images in an AWS machine learning pipeline?
Mm-hmm. Perhaps suggest best practices for transfer and pre-processing. That's a great question. Thanks for raising that. So when we talk about large images, I'm not sure how do you define large, but obviously the basic construct of copying over the data to an algorithm container will not work in this case if you have a lot of data. So there are multiple ways in which you can solve it. First would be to not use the whole copy over mode and use the stream mode. So we have two modes in our training, which is file mode and pipe mode. So file mode is the mode where you copy over the whole of the training data set to the training container, and then you do the training. And you also have pipe mode where you can stream the data one by one, instance by instance, or batch by batch to your training container so that it doesn't have to load all the data at once. So that's one way of doing it. And if you have extremely large data sets, I mean, I'm talking about probably the big, huge data sets which used to train different social networking algorithms, for example. So if you have those kind of data sets, and then you can use the SageMaker data parallelism library, which is another library which we launched in SageMaker in reInvent 2020, which is used for use cases where you have huge petabytes size or scale of data set, which you can throw to a cluster of training instances. And SageMaker data parallelism library will automatically synchronize the workers, divide the data sets by sharding, and then consolidate the result of multiple mini trainings into a single training and give you the final output. So I would say these two approaches, and obviously always go for the distributed training approach if you're dealing with large images. Probably you will be using some deep learning container like TensorFlow or PyTorch to solve that. So use distributed training approach there. Check if you need GPUs there. So we have good range of instances which you can use for GPU bound training as well, if that's something which is currently your bottleneck. So like I said, just multiple recipes, you probably need to mix all of these recipes in some combination to find the right solution.
Right. Really cool question, and interesting to hear about how to solve for that with processing large images in your machine learning training. So we had another question. Let me just find that. So with training and deployment, is there a particular way to implement machine learning algorithms?
I am not super clear on the question.
Maybe you can clear up in the chat. Otherwise, the way I understand it is how to choose between the different machine learning algorithms, what to use for specific use cases.
We don't have a universal answer to that question. It all depends upon the data set you're dealing with. You can never use the same algorithm to every business problem exactly. That's the favorite solution architect's answer.
Yes.
It depends. So it depends upon, because if you have a tabular data, and if you have an image data, and if you have social networking tweets data, you have logs, or you have videos, there would be different algorithm strategies which will work for all of these data sets. You cannot use a single one, and single one will never fit here. Similarly, when we talk about, let's say you took those decisions, but then again you need to take more decisions in terms of what evaluation metric you want to use. Again, it will depend a lot on the type of machine learning problem you're solving, whether it's a classification problem, regression problem, or a multi-class classification problem, etc. And then from that, you also need to decide what are the right hyperparameters. For example, if you're training, let's say, a GPT-2 model or GPT-3 model, they have billions of parameters. So you need to understand what you're doing there. You need to find the right combination of the parameters which you think are most relevant for your business problem and your algorithm. And that's where the expertise of data scientist will come in or kick in, where you need to take the right decision and do this again and again. You will never get to a most optimal machine learning model in one iteration or even in 5 iterations. It may take 10s or 20s or sometimes even hundreds of iterations to find the right model.
Right. So that's one reason then for training and retraining and optimizing your model to find the model and the algorithms that work for your use case.
Yeah.
All right. So we're ending the end of this stream. Today, we've talked about machine learning with Vikesh, Specialist Solutions Architect at AWS, specializing on machine learning. And we've looked at how to prepare data using SageMaker Data Wrangler. We've looked at how to train your model using that data. And then last, talk about ML Ops and SageMaker Pipelines. I posted a bunch of links in the chat for you to look more at this. But if you find machine learning as something interesting you want to learn more about, well, join us next week as well then, because we're going to talk about machine learning and AI services that time too. So we're going to look at how to minimize bias in machine learning using a service called SageMaker Clarify that was also launched at reInvent this last time, and also look a bit about computer vision and services for that. So Vikesh, any final words before we leave our viewers for this time?
Just for the people who are probably getting into machine learning for the first time, if you try to jump right into this world, this might look like a very uncharted territory and unknown territory for people. So don't try to lose focus and try to learn it bit by bit, I would say. And like I said, that if I can learn it, probably everybody else can also learn it. So
that's a humble way of ending this session. Well, Vikesh, thank you very much for joining me this week. And thanks everyone for watching. Do join us next Monday when we're back. So thanks a lot for watching.
Thanks, everyone. Bye-bye.